Well, how's everybody doing?
Good.
Yeah, so everybody's dual enroll. What class is this? What is it? Lab. Okay, just want to make sure I'm in the right class. So when I teach, I generally ask, okay, what class are you supposed to be in to make sure I'm in the right class?
This is a good question. I had a student in the wrong class, sat through all class Tuesday.
You see?
I tried. I came in and said what it was.
There's a reason that we asked the question. So is everybody having a good time so far? Yeah? Who loves math? Let's be real.
No hands. I got
No
one
hand.
maybe.
Okay, we got a kind of a half. Who hates math? All right, we got a little. All right. Who's dealing with math? Everybody, right? All right, cool. All right, well, at least we're all on the same page. So I am privileged to be here, and I thank Mr. Elrod for letting me torture you for the next 3 hours. It's 3 hours, right? We get 3 hours? Okay. You guys are like, whatever, man. I'm out of here when the bell rings, right? So what time does the bell ring? 11:40. So we got to crank this thing up and roll, right? So let's talk about math. How's it been going so far this semester? What are you about? Is this the fourth week, Mr. Elrod? Third? Are we third week?
This
End of the third week?
third?
Yeah, so we're rolling, right? Math's going good so far? Have we had a test yet?
They just turned in.
Uh-oh.
Their first quiz.
All right, how y'all feeling? What do I need to do to get you guys? Do I need to go take him and have a conversation with him?
Oh, yeah, they'd love it.
Do I need to? Yeah. All right. Me and Mr. Elrod will talk about it after y'all leave. All right. Look, math is the language of the world. Remember that. Math's a language. Math isn't something to. No. You don't have to love it, but you have to be able to use it because it is how we communicate in a lot of different ways. Just like we have a language we speak, whether it's English or Spanish or there's a lot of languages. Math is the language of how the world operates. And the great thing about math is it explains much of what you see in the world. And so hopefully that inspires you to know that there is a reason for math. And so even as, when you get older, math is helpful. What's the biggest thing math is helpful for in life? Money, just money, right? Money is important in our society, in our culture, and in our economy because you have to be able to navigate in it. And today we're going to talk about a topic that's really important is how do functions change linearly over time? And you can use this in a bunch of different ways. I love this example. I think Mr. Elrod is speaking my language because we're talking about a university's enrollment. But what are other ways you can use this theory? Who knows? Give me some examples of how this theory applies. Come on. I'm going to make you talk. I don't know if Mr. Elrod tortures you with talking, but you're going to talk with me. Who knows? Who has examples? What's that? Revenue. I love it. Wow, that's a great word. Revenue. What else? Yeah. As long as they're linear, right? We'll talk about nonlinear later, right? What else? Can I set that right here so it doesn't fall? That's to intrigue you, by the way. Are you intrigued yet? Okay, good. I'm capturing your attention. What else? Seriously, what else? How about sales tax? Over time, sales taxes, really important to our societies, right? It's how we get stuff done. It's how we build roads and hire firefighters and do all the things that we enjoy. You ever drive down a bad road and you get mad about it? But then you go to the store and you have to pay sales tax, you get mad about that too. Well, those are together. There's some way you have to pay for that. What else? What are other examples? I wrote down a couple here that I was thinking about. Interest, absolutely. How about wages? How about something that you'll be able to apply this to? Depreciation. So when you go and buy something and it's brand new, 2 years later, is it worth what you paid for? Sometimes it appreciates. It means it goes up. Most of the time it depreciates. So what's a great example? A car, right? So a car, man, cars are expensive these days. You guys got to start saving now if you want to buy a car, right? You figuring that out? Cars are really expensive. All right, but over time, 5 years, 10 years, and if you're like me, I drive a 11-year-old car. Don't judge me. I love my truck. I'll never get rid of it as long as it doesn't get rid of me. But that truck is not worth what it was when. Actually, I think the way trucks are now, it might be worth more because of the way big giant trucks are these. No, I don't have a big giant truck. You're gonna think I'm like a hot rod guy. I'm not. So there's so many ways to use this. So what I want to inspire you with is these are things that you can use all throughout your journey, and you can actually use this in the real world. Like this is real stuff. Pardon my age with my glasses. What's another one? How about utility bills? So I was jotting these down this morning. Utility bills. All right. How about the grade of a road? Right? We live in North Georgia, so there's a lot of roads. So all of these can be modeled this way. So let's take a look at this topic, and I do have some notes. So the first thing is what are a way we can use? Where's my gizmo? Is it just this one?
There's your gizmo.
You guys are gonna laugh at me, aren't you?
Pen or stylus.
Here we go.
Called the clear touch.
Here we go. You're not gonna make fun of me, Mr. Elrod. All right.
Hey, I
All right.
start from scratch.
Everybody remember this thing? Everybody remember that idea?
Someone say yes.
Please, Mr. Elrod is going to feel bad if not. All right. And what's slope? What does it mean in words? What's that? Oh, something over something. What is it?
Change over time is true.
Or what's another quick way to remember it? Yes, the rise over the run. Fantastic. So it's the rise over the run. So if we start to plot these things, right? Remember, we know coordinate systems, right? What's on the bottom? X. What goes vertical? Y. If you're old, we used to call it abscissa and other things, but that's Stone Age, right, Mr. Elrod? Okay, so X is the run, Y is the rise, right? So how do you calculate this if you have 2 points? What do you use? Y what over Y?
It's the whole formula. Y2. You
Right.
read that. Here it comes. Y2.
There you go. Right. Over. Right? Everybody remember that? It's pretty easy. Those should be lowercase y's. Sorry, my stylist skills are working. Or what? What's dependent and what's independent? So what's dependent is the rise, right? The run is generally the run is generally the independent, right? So it's also the dependent change. If you want to put this in words, it's the dependent change over the independent change, right? I'm telling you, this has use in life. I'm serious about this. Because the best example is buying something and seeing if it's really worth it. And I would always encourage you when you're making big purchases, and you haven't done this yet, but you will. Welcome to the next step of life. When you buy cars and houses and all these things, you got to think about this. Now, we hope by the way, you can use this for houses too, right? We hope they appreciate, right? We hope. That's not always the case. I've owned a lot of houses in my life, and generally, it's flat, and usually it's down. Right now, it's pretty good. We happen to be up right now. I don't know how long that's going to last. All right, so let's look at our problem. So what do we know? What's given to us in the problem? There are some things that are given to us. What's given to us? Yeah, our enrollment numbers. So what do we have here? We have a number. We have things that are given to us, right? So I always encourage you to always know what's given. And I'm kind of old school. I like to write that down. I like to say, all right, what did Mr. Elrod help me out with? If I'm taking his test, what did he help me out with? Well, what he gave me was that a starting time, right? So in 2021, enrollment was at 18,985, right? And you always have to have what on your values? Units, because that's probably like minus something on a Mr. Elrod test. If it's a Dr. Shannon test, it's going to be a minus probably something. I haven't written the test yet, but I would take points off, so you have to have units, or it doesn't matter. So you have 2021, it was this. And then you know this. We know this goes over here, right? 20,005. All right. Do we know this? We're not what are we given? What does that mean? Today, right? So you know that this is 2024, right? If not, it's a pretty good assumption, I would say. All right, so you got this. So holy cow, Dr. Shannon, you mean to tell me I've got, and I know what you're thinking, all right, Dr. Shannon, I hate math, but you're getting pretty good. You got 4 things. You got, I mean, we're doing good here, right? So now how do we find this slope of this formalism here? How do we find that slope? What do we do? Did you say plug? Who said plug? I'm picking on you. Plug and chug, right? The more elegant way is to you would substitute the values into the equation. That's more elegant, but we'll plug it in, right? I'm picking on you. But you guys have to have fun. Math, I know, is not the most exciting thing in the world, but we're trying to make it fun. It is actually interesting.
The teacher wasn't very elegant because he just said plug it in on Wednesday.
Oh, Mr. Elrod, you are just not elegant. All right. So, when we say slope and we do this through the equation of the line, what's the symbolism that we use? Anybody remember? It's a great letter. I love this letter. This is the most wonderful letter ever created. What do you use?
Letter for slope, guys.
M. My first name is Michael. I love Michael. I love M.
No bias at all.
I know. So, M. I know what you're thinking. Does that mean you love yourself? No, I just love the name. I think it's cool. But you can call me Mike because my mom named me Michael, but she calls me Mike. It's kind of a funny story. So, M equals, so what's Y2 in this case? This is 1, this is 2. It's that number there, right? We good? All right. So we go 20,005. What's the next number?
18,900.
Yeah. Sorry for my board skills. These have gotten a lot better, by the way. They used to be really wonky. Remember the
I had something called a Promethean years ago. This thing's called a Clear Touch, and of course I have some
I
more
think it's better.
smart boards on campus. So
Absolutely. So now this gets a little tricky. Now, if you put the 2 dates in, it does actually work, but we don't want to do that, right? So what do we know about these data? Well, what we know is this is the starting condition, which is at 0, right? And this is the ending condition. And so what's the difference between the two? 3. So we want to go 3 minus 0. Right? Now, the dates would work, but that's convenient. Not always the case. Okay, so don't get that. All right, so who's got the math here? You guys can roll this out. Somebody can be the hero right now. Give me the math. What do we got? What's that big number minus that big number? Yeah, I get 1,022. Or as well. And then who can do 3 minus 0? Yes, ma'am. Yes. Fantastic. For the win. And then what do we get? What's our slope? 340. Everybody following this so far? All right. Everybody, see, this isn't that bad, is it? I know when you read this, it gets a little bit crazy and you get a little bit nervous and scared, but it's really not that bad. All right? So again, why do we let t equal to, what are we doing here with 2021? What are we doing with this? We're letting this be t equal to 0, right? Everybody remember that? That's how we get this here. Why? Do we know anything about 2020, 2019, 2018, 2017? Do we know anything before? No, we don't know anything about it. All we know is we're starting here and we're going here, and the rest of it doesn't matter, so at that point it's t equal to 0. Everybody cool with that? So you got to kind of talk yourself through this and say, all right, what do I know? What don't I know? And then go from there. All right, so we got this guy straight. Remember now this one. This is the next one you need to know. All right? Who remembers this slope-intercept form?
We had a football player say it correctly, if you can believe it.
Really? I love it. Who remembers this? That's an M.
All right, Pacheco.
Y equals mx plus b. I love it. All right? So y equals mx plus b. Everybody remember that? The equation of a line. My most favorite formalism in algebra. I love y equals mx plus b. It's really powerful. All right, so what do we know about that? Let's talk about it a little bit. What's b? B is easy. We just talked about it. What is b? It's our y-intercept. What's m? It's our slope. What else do we know? What's x in this case? Yeah. In this case, it's our time, right? Absolutely. Variable. I love it. That's true, but not exactly what we're driving at. All right? So now, you could start to put this together pretty quickly, right? This becomes pretty simple. All right? So, what if we wrote this in function form? If we said enrollment as a function of time, right? This is a function of time, right? You get that formalism. How do we write that? What's our notation? Everybody remember this? Let me write this up here. Enrollment, we're going to say, is defined as, right? It's this idea of E, right? So if we say E of T, does that make anybody nervous? Enrollment as a, remember, math is a language. It speaks to you. Say it out loud. Talk to yourself. I'm giving you permission to be weird. Hopefully you're alone. But if you're at home, you can show your parents, man, I'm really smart because I figured this out. Talk to yourself. Enrollment as a function of time. Because when you talk yourself through it, it starts to make sense. So enrollment as a function of time equals what? Let's start to go through this. By the way, that's the same thing as that. Everybody see that? The y is enrollment as a function of time. Everybody see that? So now, what can we do? We can take this and we can start to solve this. Enrollment as a function of time equals what? Because that's what we're trying to solve for, right? We're trying to solve for that over time. So how do we do this? Well, we have the slope, right? What is it? 340. Because remember what we're trying to do here. We're trying to write a linear function that models this. And Mr. Elrod already told you, it's e of t. He already told you all this. Man, he gives you too much information, I think. I think he gave you way too much here. He already told you the answer. All right? So what's the next part of the equation? In this case, it's not x, it's t. So 340t, right? Then what? Plus the y-intercept. So here's the million-dollar question. This is the A question of the day. What in this case is the y-intercept? Yes. Why? What is the y-intercept always related to? 0. Yes. So remember, the y-intercept is always related to when x equals 0 every time.